Good morning, class. I just want to review a few of the topics that you'll be needing for your very last test in college algebra. So, we'll start with even and odd functions. First of all, to have an odd function, you want to sub in negative x and get the opposite signs in your function, or you want to look at symmetry and make sure there's symmetry in the origin. For an even function, you want to sub in negative x, and you want to get the same signs that the function had, and you want to see symmetry in the y-axis, which means that technically what you want to do is you want to either look at the graph or try the algebraic test. So we're going to go over problem number 8, two problems in problem number 8. On your sheet that you have as a review sheet, 8a gives you this function, and this is what it looks like on your graphing calculator. If you took it and you turned your graphing calculator upside down, you should look at the same picture. That means that you have symmetry in the origin. So I have it typed into my graphing calculator, and this is what my picture looked like. Obviously, I'm not going to take this board and turn it upside down, but I will show you on the calculator what it looks like. So here we are, we're graphed. This looks like it has symmetry in the origin. If I turn my calculator upside down, in fact, it looks like the same exact function. So I am using the graphing approach to show you that this function is in fact an odd function. Next, I want you to take a look at 8c. This is the function that 8c is. I'm going to put that in my graphing calculator. And what I'm going to look for this time is I'm going to try to see if I can find some symmetry in the y-axis. I'm using, again, the graphing approach to finding even and odd functions. So your graph looks like an M shape. Here it is, an M shape. I'm not turning it upside down. I just want to see that along the y-axis I have some symmetry, which means it looks like exactly the same thing on the left side of the y-axis and the right side of the y-axis, and in fact this one does. So I use the graphing approach for these, and when you later look at the answer key, you can see that I will also use the algebraic approach. So there's two of your answers. 8a is odd, 8c is even. The next thing I'd like to review with you is the right triangle trigonometry. I've made up this problem here. I'm putting a 10-foot ladder against a wall. I'm trying to figure out how high up the wall it goes. I know that the ladder makes a 20-degree angle with the ground. So I'm looking at the opposite side of the angle, and the hypotenuse side would be the ladder. So opposite over hypotenuse is my sine function. Sine of 20 is equal to x over 10. Make this cross multiply. X equals 10 sine 20. 10 times the sine of 20 is approximately 3.42. Therefore, my answer is approximately 3.42 to the nearest hundredth there. Last topic I'd like to go over with you for part of your review are trig graphs. This is a typical sinusoid, y equals -2 sine x minus pi over 2. The amplitude for this function is always positive, so therefore the amplitude for this function, the a value is -2, absolute value would be +2, amplitude is 2. My phase shift is how far to the left or right it goes. Recall that x is what I always call confused, which means it seems to go in the other direction than you would expect it to. Therefore, the phase shift here is pi over 2 to the right. If they ask me about the period of this function, the period is 2 pi over b. This b is just 1. So therefore, the period is 2 pi over 1, also known as 2 pi. That was a very easy problem. If b was a fraction, you'd have to flip and multiply it to the top. In order to convert from radians to degrees, we multiply by 180 over pi. Therefore, I cross out my pi's here. I divide 5 into 180. 5 goes into 180. So 5 goes into 18 how many times? 3. With a remainder of 3, so 36. I'm going to multiply 6 times 36, and I'm going to get 146. I'm sorry, 246. Okay? 70 times 180, times pi over 180 to go the other way. We put 70 over 180. Let's reduce that in our calculator. 70 divided by 180, math, enter, enter. That's 7 over 18, which means I'm going to say 7 pi over 18 radians. Okay, we could have also done our last problem using the graphing calculator, and that would have been 6 times 180 divided by 5, and that's 216. Oops. So I made a multiplying error, 216 degrees. Okay, we're good? I will go over the last part of the review on Wednesday. Have a great day, guys.